In this lesson, we're going to solve quadratic equations using the quadratic formula. In order to use the quadratic formula, your quadratic equation must be in standard form, which means it must be set equal to 0. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this example, you first need to make sure it's set equal to 0. Yes, it is. It's in standard form. Then let's identify a, b, and c. A is 2, b is negative 11, c is 5. And we're going to substitute these values for a, b, and c into the quadratic formula. So the opposite of b will have 11 plus or minus the square root of b squared, which will be 121, minus 4 times a, which is 2, times c, which is 5, and this is all over 2a, or 2 times 2. So as we continue to simplify, we'll have 11 plus or minus 121 minus 4 times 2 times 5, which is 40, all over 4. We have 11 plus or minus, all right, 121 minus 40 is 81, all over 4. Now I want to point out here the number underneath the radical, which is 81. 81 is a perfect square, so that means our answer is going to be 2 rational numbers. All right, continuing to simplify, x will equal 11 plus or minus 9 over 4. And if we split this up into 2 separate expressions for x, x will equal 11 minus 9 over 4, and x will equal 11 plus 9 over 4. So here, x will equal 2/4, or 1/2. Here, x will equal 20 over 4, or 5. So our two solutions are 1/2 and 5. Another example using the quadratic formula. Again, our equation is in standard form. It's set equal to 0. Identifying a, b, and c. A is 2, b is negative 4, c is negative 2. Substituting these values into the quadratic formula, the opposite of b will be 4, plus or minus. B squared is 16 minus 4 times a, which is 2, times c, which is negative 2, all over 2 times 2. Further simplifying, 4 plus or minus, we now have 16 plus 4 times 2 times the negative 2, we'll end up with 16 all over 4. Now, further simplifying, 4 plus or minus the square root of 32 all over 4. Now I want to stop and point out the number underneath the radical, which is 32. Now that is a positive number, but 32 is not a perfect square, so our solution will be 2 irrational solutions, which will end up being irrational conjugates of each other. Continuing to simplify, 4 plus or minus, all right, 32 is 16 times 2, if we're going to simplify this radical. So we'll have 4 radical 2 over 4. Further simplifying here, 4 goes into itself once, 4 goes into itself once, goes into itself once there. So we're left with 1 plus or minus radical 2. So our solutions are 1 minus radical 2, 1 plus radical 2. Here are our 2 irrational solutions, which are conjugates of each other.